In section 17.3, you will learn heats of fusion, solidification, vaporization, and condensation. In other words, the amount of heat absorbed or released when a substance melts, solidifies, vaporizes, and condenses. First, we have the molar heat of fusion, which is the amount of heat absorbed by 1 mole when a substance changes from a solid to a liquid or melting, making this an endothermic reaction. A solid gains heat when it changes to a liquid, and the temperature varies among the substance because there are particles that are already melted and particles that are not during the melting process. Once the substance has fully melted, the overall temperature of the substance has been increased.
This is an ice cube melting. In this situation, the ice is absorbing heat energy from the air around it and the surface it is sitting on. Not all particles go through the phase change at once, so the temperatures of the particles vary.
Here are some practice problems that pertain to the molar heat of fusion. Pause the video in between problems to solve it on your own first, then watch the solution. Number 1. How many kilojoules of heat are required to melt 15 grams of ice at 0 degrees Celsius? The heat of fusion of water is given at 6.01 kilojoules per mole, and the mass of ice is given at 15 grams. What we need to find is the amount of heat required to melt the ice. First, we need to convert the 15 grams of ice into moles by doing dimensional analysis. 1 mole of ice is the same as water, which is 18 grams. 15 grams divided by 18 moles per gram is about 0.83 moles. Then you would multiply this by 6.01 kilojoules per mole to find the amount of heat required in kilojoules. The answer would be about 5 kilojoules since the moles would cancel out. Number 2. How many grams of ice at 0 degrees Celsius can melt with 1 kilojoule of heat added? The amount of heat per 1 mole of water is given as 6.01 kilojoules per mole, and the amount of heat used is given as 1 kilojoule. We just need to find the number of grams of ice that can melt with 1 kilojoule. First, we need to convert the kilojoule to mole by dividing 1 kilojoule by 6.01 kilojoules per mole. Then you multiply 0.17 moles by 18 grams of water per mole to find the grams of ice. The solution would be about 3 grams of water since the moles cancel out. Next, we have the molar heat of solidification, which is heat loss of 1 mole of a substance when it changes to a solid from a liquid or condenses. When a substance condenses, the heat is released from the substance to its surroundings, making this an exothermic reaction. The amount of heat of a substance when it solidifies or melts are corresponding, but the amount of heat of a substance when it solidifies turns negative, while the substance that changes from a liquid to a solid is positive.
In the other direction, going from a liquid to a solid, the water in this bottle releases heat energy that is absorbed by its surroundings.
The molar heat of vaporization is the amount of heat needed in order for a mole of a liquid to change to a gas or evaporate. When a liquid substance vaporizes, the liquid absorbs heat from its surroundings and changes to a gas, making this an endothermic reaction.
Here we have boiling water. The heat energy is being released by the burning gas, absorbed by the pot, then released and absorbed by the water, and it in turn vaporizes into steam.
Now let's do some practice problems pertaining to the molar heat of vaporization. How many kilojoules of heat are absorbed when 70 grams of water at 100 degrees Celsius and 100.3 kPa is changed to steam at 100 degrees Celsius? The mass of water is given as 70 grams and the amount of heat per mole of vaporization is given as 40.7 kilojoule per mole. In order to find the kilojoules of heat absorbed, first we need to convert the grams of water to moles. You do this by dividing 70 grams of water by 18 grams of water per mole, and you get about 3.9 moles. Next, you multiply 3.9 moles by 40.7 kilojoules per mole to find the kilojoules of heat. The solution is about 158.28 kilojoules because the moles cancel out. On the other hand, the molar heat of condensation is the amount of heat released when 1 mole of a gas substance changes to a liquid or condenses. When a gas changes to a liquid through condensation, the gas substance releases its energy, making this an exothermic reaction. Just like how the molar heat of fusion and the molar heat of solidification are the opposite, so are the molar heat of vaporization and condensation. The amount of heat a substance that vaporizes and condenses are corresponding, but the amount of heat a substance that condenses has a negative sign.
A glass of water sits in a room temperature area. As particles of water vapor in the warmer air surrounding the glass hit the glass, they cool and release heat energy to condense and form water on the outside of the glass.
This picture shows the enthalpy changes of water during each phase change. An enthalpy change is the energy change of a substance like the amount of energy. For an example, in a molar heat of vaporization, the enthalpy change is positive because the substance gains heat. Also, the picture portrays that the temperature is constant when a substance is phase changing.